They roamed the planet for longer than modern man. Neanderthals.
Neanderthals were superb survivors.
They survived in a treacherous world.
They really dominated Ice Age Europe.
Fearless hunters who possessed superior strength and surprisingly advanced tools.
It's perhaps one of the most efficient technologies we've ever seen in the entire Stone Age.
But then suddenly they vanished, and no one knows why.
It's still one of the most wondrous mysteries.
Was it a clash with modern humans?
This may be the best case of a Neanderthal murder victim.
Around the globe, scientists are searching for answers.
This is a modern human with Neanderthal features.
And they find clues in unlikely places. An ancient volcano site in southern Italy.
The ground at the moment is rising.
In the Greenland ice sheet, far from the grounds where Neanderthals once settled.
There's a cluster in here, thin layers.
Mounting evidence reveals a surprising new theory. It was not war with modern man that killed off the Neanderthals. It was an apocalypse that might have sealed the fate of our closest human relatives. And what happened to them could easily happen to us. Gibraltar, at the tip of the Iberian Peninsula. Here along the Mediterranean coast, a vast complex of caves dot the shoreline. Today, waves encroach upon them. But 24,000 years ago, with the height of the last ice age fast approaching, the sea level was more than 100 feet lower. This was dry land, home to the very last of the Neanderthals.
When we look at the number of sites with Neanderthal fossils and/or evidence of occupation, I don't think there's any place in the world that has the density of sites per square kilometer that Gibraltar has. Gibraltar was their stronghold. This is where the population was continuous. It was a place that they lived and liked and survived for a long time. The conditions there were good. And because they were so good, they persisted longer than anywhere else.
In this enclave, amid forests of pine, hunters search for prey. Along the shore, Neanderthals fish, living as they have for generations before, unaware that they are the last of a dying breed.
They probably didn't realize when their neighboring group further north disappeared that they were on the verge of extinction. They had no way of knowing that.
Once their species flourished across Europe and Asia, now their population has dwindled to just a few clans, here in the south of the Iberian Peninsula. But what ultimately drove the Neanderthal to extinction? The Gibraltar Caves may hold some clues. Paleontologists Clive and Geraldine Finlayson have studied this site for many years and are leading a massive excavation effort.
So these caves here all lined up, it's almost like a Neanderthal city. This is a place where Neanderthals were living for a long time, occupying all of them. In some cases now the sea has gone in and we've lost the evidence, but we still have a lot of material there for excavation.
Inside the caves, teams of archaeologists search for remnants of Neanderthals' past.
Everything about the cave looks right for a Neanderthal. We sort of get a feeling for these things.
They're unearthing bones and remains, as well as tools and artifacts linked to Neanderthal by their distinct shapes and craftsmanship.
So this piece, this is a core, and they'll use this to extract flakes from it. This is a technique that can be associated with Neanderthals.
With every find, they are gaining new insights into the Neanderthal themselves.
Here we have the remains of a campfire from the Neanderthals, radiocarbon dated to about 47,000 years ago. You can see the concentration of charcoal, particularly here in the center of the fire. And it's a fantastic resource for us because we can date it, but also we can dissect the charcoal and find out the plants that were growing out there. So it's fantastic. So 47,000 years ago, for some reason, this is the place they liked. Maybe it was a mild climate out there, but they were sufficiently sheltered, and the Neanderthals were sitting here. And we found remains of deer and other animals they'd been eating, and they had a big fire going here.
Here for generations, Neanderthal families gathered around the fire and prepared meals together. A far cry from the ape men scientists imagined when the species was discovered in Germany in 1856. Other finds reveal details of a rich and multifaceted culture, an aspect of the species that is only now being recognized.
Here's a very interesting bone. It's from a bird, a scavenger that eats almost exclusively bones. It's got cut marks, so it shows that they've been processed by the Neanderthals. But we don't think they're eating them. What we think is happening with these large birds is that they're getting them for their feathers. These birds have colorful feathers, some of them large, dark feathers, and we think that they're using them to wear them.
Other artifacts suggest Neanderthals adorned their bodies with body paint and jewelry, creating a vibrant, personal display.
So this gives us a completely new dimension, something we hadn't suspected until we started to discover these things here. What it means, I think, is that they had ways of symbolizing, abstracting the world. They had ways of communicating by signaling, ornamenting themselves.
Deeper still in the cave, there are even more remarkable signs of Neanderthal life. The passageway winds towards a recently excavated chamber.
So we're just coming to what must have been one of the favorite spots of the Neanderthals, just here. We find evidence for something that would have been not suspected a few years ago.
The first discovery of a Neanderthal rock engraving. A grid pattern, carbon dated to at least 39,000 years ago. Scientists believe the Neanderthal carver intended it as a clan marker, perhaps staking a claim to the cave. The marker is a clue that Neanderthals, like modern humans, were capable of abstract thought, and it challenges the belief that Neanderthal were the intellectually inferior species.
They may not have spoken the same language, they may not have thought that beautiful things were what we think as beautiful things, but they had the capacity for abstraction, and I have no doubt that they have similar cognitive abilities to modern humans.
A different picture of Neanderthal is now emerging. That of a species more like us than we ever imagined. Then why and how did they vanish from the world? Who were the Neanderthal? Their story begins 600,000 years ago in Africa with another species, the evolutionary ancestors of both Neanderthal and modern humans, Homo heidelbergensis. They are the first humans known to harness the power of fire and hunt with wooden spears.
They've advanced over more ancient people. They have bigger brains. They have adapted in a human-like way. But it has none of the specializations that are in Neanderthals, and it doesn't have the specializations that are in modern humans. They're not either like us or like Neanderthals. They're ancestors of us both.
In pursuit of more abundant game, Some head out of Africa, into Asia. Others settle across Europe, including in what is now Heidelberg, Germany, where their bones are first discovered.
When they left Africa and entered Central Asia and Europe, they would have been experiencing a harsher climate in many ways.
It's a time of great climactic change, brought on by a slight shift of the Earth's axis that tilts the North Pole away from the Sun. The polar caps expand, moving across North America and Northern Europe. Temperatures drop by as much as 20 degrees in the Northern Hemisphere. 300 to 400,000 years ago in Europe, the Ice Age elements forge a new breed of man. Homo neanderthalensis, the Neanderthal.
Where they lived, in Europe and Central Asia, these were the coldest places in human existence in those times. So they were adapting to that.
Their complexion has become lighter compared to their African ancestors, enhancing absorption of sunlight during the shorter northern days. Their hair is straight and thick, added protection from the cold. They have a muscular build, more fit for the rugged terrain.
They were strong and amazingly healthy. They were, in fact, an extraordinary population.
Along with their physical adaptations, Neanderthals find strength and safety in numbers. They live in tight-knit clans, dedicated to the care and protection of each other.
You're looking at people that have lived in a challenging landscape for hundreds of thousands of years. These lives are short, and they rely on their groups for their children to be able to survive because the parents might not.
By banding together, Neanderthals survive the hardships and thrive in this Ice Age environment. Numbering in the tens of thousands, they spread across Europe, the Middle East, Central Asia, and as far north as Siberia.
They were mobile. They're able to get what they need from the landscape where they are. So they're collecting raw materials for tools, and they carry them tens of kilometers, maybe hundreds of kilometers with them sometimes. They're moving in pursuit of being able to find food and survive.
And in this world of frigid earth, where vegetation is scarce, their survival depends on the animals they hunt. They follow wandering herds of bison and stalk more evasive prey, like deer.
Their ability to provide resources like vegetation and roots and tubers and fruits was probably extremely limited. They were forced to eat mainly hunted animals.
Their hunting tool is the thrusting spear, a powerful weapon, but only useful if the prey is within arm's reach. This makes every hunt a most dangerous game.
But you can't be unintelligent about it, right? You have to know when it's worth taking the risk.
A herd of bison roams the valley, unaware of the hunter's approach. The well-coordinated team closes in on their quarry and then goes in for the kill.
If your hunting method requires you to jump on a bison with a spear, that's what you call fearless.
Each hunt is a life or death undertaking, but the supply of fresh meat is worth the risk.
Neanderthals would have had to be brutally efficient when it came to using the food that they got. Using the food in their environment and using every part of the animals that they hunted.
When they return to camp, the hunters butcher their prize using razor-sharp blades made of flint. They cook their meat over an open fire, rendering the toughest chunks more digestible. They scrape and stretch the hide, making the leather soft and pliable.
They're creating the hides for them to make some clothing out of to wear. They're using rock to make tools rapidly. They were able to master the environment that they lived in.
For now, Neanderthals are masters of their world. But one day, their rule will be threatened by another species, our direct ancestors, modern humans. 40,000 years ago, Ice Age Europe. Here, Neanderthals have survived and thrived for 300,000 years. They alone have been the masters of this land. But now they face their greatest challenge. A new species has entered their territory. Homo sapiens, modern humans. Like Neanderthal, they are the evolutionary descendants of Homo heidelbergensis. They first emerged 200,000 years ago on the savannas of Africa. 80 to 60,000 years ago, groups of modern humans headed north in search of more fertile hunting grounds into the Middle East and Asia. And a few pushed west, entering Neanderthals' European homeland. They carry throwing spears, a weapon built to kill from a distance. And they are different in appearance.
Evolving in Africa, where water bodies were more and more scattered, it promoted natural selection towards ability to move over large distances quickly, becoming an endurance runner. And with that, a technology that is lightweight, portable, that you can carry around.
The newcomers are hunters. And they come seeking the land and game Neanderthals claim as their own.
Whenever human populations come into contact, historically, there's always cases of warfare. These guys are coming, they're trying to steal our land, we have to fight them. And you always see that. Whenever you see modern humans disperse, I have to believe that Neanderthals and modern humans would have been the same way.
For over a century, many scientists have marked this as the beginning of the end for Neanderthal. Within 10,000 years of modern humans' arrival, Neanderthals would disappear across most of Europe. The timing seems more than coincidental for many scientists.
In this theory, Neanderthals were extinguished by invading modern humans.
And there is tantalizing evidence linked to this theory. A clue from what might be the world's oldest cold case. A 40 to 50,000 year old rib from a Neanderthal skeleton found in an Iraqi cave. It bears the mark of a fatal wound.
This may be the best case of a Neanderthal murder victim.
But who is the killer? There are only two possibilities: another Neanderthal or an invading Homo sapien. In Mettmann, Germany, at the Neanderthal Museum, forensic anthropologist John Hawks examines the ancient evidence, searching for answers.
The thing is that this rib has this big gash in it. It was clearly made by some sort of stone point or a sharp edge. The next door rib, the 8th rib, has only a very minor reaction on it. So that indicates that the point that made this injury was very small.
This suggests a precision-cut blade, a weapon unlike the heavy Neanderthal thrusting spear.
Some sort of small point made this injury punched into the thoracic column. The
blade entered at a 45-degree angle. the downward trajectory suggests a weapon thrown overhead.
So that indicates that this was a projectile point made by a modern human.
This is evidence that there was conflict between the species. And in this encounter, a Neanderthal clearly lost. But other evidence suggests these confrontations may not have been so one-sided.
Reconstructions of the Neanderthals show them to be relatively short and stocky, with short extremities and relatively barrel chests.
Based on the latest evidence, the Neanderthal would have been, at the very least, a formidable opponent.
The remains of muscle markings left on the bones show extraordinary strength.
This muscular frame gave them the ability to contend with threats close at hand. For Neanderthal, a species that confronted 2-ton bison head-on, a modern human attacker would have been a lightweight foe. Neanderthal was shorter than his modern human challenger, on average 4 to 5 inches. But because of greater muscle mass, he would weigh the same. Neanderthal's pectoral muscles were twice the size of the average modern humans. With a more muscular upper body, scientists believe that a Neanderthal could produce 80 to 90% more force than a modern human.
You know, if they did arm wrestling, I suspect the Neanderthals would beat everybody, including the ex-governor of California. I think he would not stand a chance.
And their greater muscularity reveals another fact. The Neanderthal body was riddled with androgens, sex hormones.
Neanderthals had naturally a greater amount of occurring androgens, which developed their muscularity and the denseness of their bones.
And androgens, like steroids, have a well-known side effect.
They may have been a little more aggressive, and so they may have been somewhat more dangerous than modern humans.
Entering Neanderthal territory could have posed a risk for modern humans.
Maybe we didn't win as many battles as we would like to think. That perhaps the Neanderthals on home territory knew what they were on about, and maybe they succeeded more often than we realize.
Neanderthal strength likely gave them the advantage in most violent clashes. But survival would also depend on the ability to cope with a bitter Ice Age climate. Who was best physically built to withstand extreme cold? The muscular, stocky Neanderthal or the tall, lean, modern human?
Yeah, come on over. So we're gonna gear you guys up here in a minute.
To find out, we're putting 2 volunteers with 2 distinct body types to the test in a deep freeze environment. We're at a California cryotherapy center that uses extreme cold to enhance healing and recovery for athletes.
Okay, we're about to expose Jason and Matt, 2 very different body types, to minus 166 degrees Fahrenheit to determine how their bodies react to the cold temperature.
One of the volunteers stands tall for modern man. The other, stocky and muscular, like Neanderthal. Before they're exposed to the extreme cold, the men protect their hands, face, ears, and head.
We're gonna be using thermal imaging to take a look at both pre and post-treatment.
But first, a pre-test skin temperature reading.
96 degrees. 95 degrees, so very similar. Okay, let's go ahead and go. They're gonna enter the pre-chamber here for 30 seconds. This part of the process sort of acclimatizes the body and prepares it for the much colder temperature in the treatment chamber.
All right, go and enter the main chamber.
They're now in the main chamber of minus 166.
This is 30 degrees colder than the lowest temperature ever recorded on Earth. For this test, our subjects will endure a survivable but excruciating 3 minutes in the cryochamber. Much longer, and they risk hypothermia, shock, and even death.
2 minutes.
Lab technicians closely monitored the volunteers.
One minute left. 1 minute. Seconds. Time's up. Don't exit the chamber.
Okay, so they're going to be exiting the chamber here, and we're going to get skin temperatures. Call it out.
56, 51.
The volunteer with the more muscular build has retained a higher skin temperature.
So you can see here that Jason's internal temperature, muscle temperature, is several degrees higher than Matt's.
Under thermal imaging, the advantages of a stocky frame become even more apparent. The warmest areas are shown in red, the coldest in blue. But that's not all.
It's interesting, you can see during this minute while they're out, they're starting to rewarm. And Jason actually is starting to rewarm pretty rapidly.
The more muscular body also recovers faster. But why?
Around the skeletal area, where the muscle is, there's more vascularity. You're getting circulation in those areas pretty rapidly.
Because they evolved in a cold climate, Neanderthals developed a body type tailor-made for the world they lived in. They possessed superior physical strength and stamina. So what advantage did modern humans have? It must have been brain power. Neanderthals were stronger and better adapted to the cold than modern man. But when it comes to intelligence, Neanderthals have always had a bad reputation.
This brutish guy with a club pounding on the head of his mate and dragging her into a cave, that is what the Neanderthal has come to represent.
It's a reputation that goes back to the discovery of the species.
Neanderthals were recognized in 1856, and you have to think that in those days, Europeans were envisioning a human past that was very primitive, and Neanderthals fit right into that.
What stuck out to scientists was Neanderthals' protruding brow, the mark of a species not quite human and less intelligent. But how does Neanderthals' brain actually compare to our own? For forensic anthropologist John Hawks, this is the kind of comparison that sparked his interest in Neanderthal 20 years ago.
I started working with Neanderthals when I was in graduate school. The cool thing about Neanderthals is that they're so close to us, and yet there's like this division between them and us. And so looking at them gives us a look at ourselves through maybe a sort of a distorted kind of a lens.
Using 3D imaging technology, Hawks studies Neanderthal skulls excavated in France. The technology allows him to peer inside the skull and glean insights about the Neanderthal brain.
It has a very pronounced brow ridge right on the outside of it. And you might think, wow, that must impact the shape of the front of the brain, which is right behind it. Yeah, I like the way that you've lined it up there.
Like a 3D X-ray, a laser scanner captures every detail outside and inside the skull.
When you turn this frontal bone over and look at the inside of it, what you see is the frontal lobes of the brain that are imprinted in the back of that bone.
The marks left in the bone allow the scientists to calculate the size of the frontal lobes, the area of the brain involved with cognitive processes.
The imprint inside of it, of those frontal lobes, is basically the same as ours.
Within the frontal lobes lie the prefrontal cortex, the area responsible for critical thinking, problem solving, and creativity. The results of Hock's analysis reveal a brain that's remarkably similar to our own.
The parts of the brain that are responsible for language capacity, the parts of the brain that are responsible for really thinking about stuff, seem to be the same size and proportion in Neanderthals as they are in humans.
But surprisingly, there's one area where Neanderthals' brain differs from ours.
The back part is a little extended, right inside that occipital bun, and it's possible that that makes a difference to the functions of the back of the brain.
The occipital bun contains the occipital lobe, the area involved with processing visual information like pattern recognition and depth perception. For hunters, these are critical visual clues used to identify prey and hit their target with deadly accuracy. This points to Neanderthals having exceptional vision.
So this is a possible functional difference between Neanderthals and us.
But the true measure of Neanderthals' brain power lies in how they applied it to survive challenges in their environment, and how they kept pace with the inventions of their modern human rivals. The best examples are the tools they built. To the untrained eye, Neanderthal knives appear crude, even primitive, especially when compared to the precision-chiseled blades and spearheads crafted by modern humans.
Neanderthals would make knives that basically would get done in a couple minutes at most. So rather than trying to impress with how fancy their technology looks, they're interested in getting the job done. Modern Homo sapien technology seems to be a lot more elegant. A piece like this would take several hours to make, sometimes a day.
But a quickly made knife is not necessarily an inferior one.
For a Neanderthal to make a spearhead, it's just not a lucky blow. Neanderthals were able to create their stone flakes that not only had incredibly sharp edges, but the edges were incredibly strong.
Archaeologist Metin Eren is uncovering Neanderthal tool-making techniques by replicating their methods.
While it looks easy to make these stone flakes, it actually took me about 1.5 years to learn how to make and replicate the same exact technology that Neanderthals did. One reason why the Neanderthal technology is so hard is that it's necessary to get a precise geometry in the rock that you're making.
Neanderthal stonecutters targeted small fissures and cracks. In a sense, they saw the blade within each rock and struck accordingly. A visionary technique.
A Neanderthal could easily make 50 to 60 to 70 stone flakes from a single nodule of flint. So I think in a very real sense, you could say it was almost assembly line stone flake production.
A side-by-side comparison with a modern-day knife shows just how effective the Neanderthal blade is. The metal knife requires lots of effort. The Neanderthal stone blade slices with ease.
Neanderthal knives were as sharp as anything that we would have today. And it really just speaks to how sophisticated their technology was.
And how well they were able to use the materials at their disposal. With their stone blades, Neanderthals turn a basic assumption upside down. They prove that when it comes to technology, they are on par with modern man. And there is at least one instance where Neanderthals' innovation surpasses that of our own species. This seemingly unremarkable object, uncovered in a German mine in 1963, is a piece of technological history. This 50,000-year-old artifact bears the stamp of its original Neanderthal owner.
This is an It's a very small, black, unremarkable thing, but it's a sensation. What you can see here is an imprint from wood. And when you turn it around, there is another imprint of a stone point. And below that, a Neanderthal fingerprint.
What's so remarkable for chemist Christian Wunderlich isn't just the maker's mark, it's the substance itself. Chemical analysis reveals that it does not occur in nature, making it the world's oldest synthetic material. It's an adhesive distilled from birch bark called pitch, a kind of Stone Age superglue. Neanderthals used pitch to form a rock-hard bond between stone blades and wooden shafts, making their thrusting spears more durable and deadly. But the most impressive part of the landmark adhesive is the process involved with its production. A process that scientists could only figure out in the controlled environment of a lab.
You have to invent this and tinker with the recipe in order to do it properly, and it's hard for us to learn how to do.
Birch pitch only emerges when the bark is heated to around 750 degrees Fahrenheit. The problem is, in open air, the bark ignites at much lower temperatures. So how did the Neanderthals do it? Christian Wunderlich and a colleague are attempting to make pitch using only materials available to Neanderthals. First, they place the birch bark in a container, like the goose egg seen here. Next, an empty container with a wider opening is buried in the ground. It will later collect the pitch. Then Wunderlich places the container with the birch bark on top of it. Mud is then applied to seal the two containers, preventing oxygen from rushing in and sparking the ignition process.
The birch pitch that they're creating in order to use as a glue to adhere things together, it's so complicated, the steps that you have to carry out to create this accurately. And they're doing it, and they're doing it apparently for long periods of time.
Hot coals are used to heat the birch bark inside the goose egg container. As temperatures rise to 750 degrees Fahrenheit, the oily pitch will begin to ooze out.
Normally, 30% of the birch bark becomes pitch.
The entire procedure takes 20 to 30 minutes, but the process itself is over 200,000 years in the making. A testament to the intellect of Neanderthal, and proof that they, like modern humans, had the ability to innovate and invent, to see possibilities in nature and mold them for their own advantage and survival.
What technology really is the ability to follow directions, carry them out to create something that's useful to you. And Neanderthals, they're able to do these things. They're learning from other Neanderthals, and they're carrying out those things long before modern humans show up on the scene. So we're just getting a little glimpse of the sophistication that Neanderthals probably had.
But for all their sophistication, Neanderthal technology may have had one fatal flaw. Experts now understand that Neanderthals were physically stronger than their Homo sapien rivals, and equally as intelligent and innovative. Why then did they disappear while modern man survived? Could their different hunting techniques be the key? Neanderthals attacked their prey with thrusting spears, a heavy, handheld weapon. Modern humans pursued their quarry, armed with throwing spears. Pitted against modern men and their throwing spears, did the Neanderthals die out because they were simply out-hunted? In Petaluma, California, weapons expert Mike Lodes and his colleague Scott Thomas will put Neanderthal and modern human spears to the test. Their target, a pig carcass.
It's a good height. We've got the height. Got the height.
First up, the modern human throwing spear.
This is not the Olympics. We're not throwing for hundreds of meters. This is hunting, and it's hunting in a group. So I have got my friends the other side of that animal. I'm not throwing for distance, I'm throwing for penetration and accuracy. So probably no more than 6 to 8 meters, even as close as this, is a reasonable hunting distance.
Like Neanderthal, modern man needed to get close to their prey. But how deadly is the modern human throwing spear?
We can see already that the impact of that strike has actually sheared the stone head off. Now, in terms of doing damage to the animal, that doesn't matter too much. You know, this has penetrated. In fact, if we look around here, yeah, it's come right through.
But how will this compare to the killing power of the thrusting spear?
Neanderthals tended to hunt the big game, the big aggressive animals like mammoths and bisons, big creatures that run at you. And in that situation, I do not want to throw my weapon away.
This time, Lodes will strike the target using all of his strength, Neanderthal style.
That has gone in pretty convincingly. I mean, we can see it's past the shoulder. It's gone in deeper than the thrown one. And clearly the thrown spear is a higher velocity event than the thrust one. But that little extra bit of muscle power, even my weak modern human muscle power, has been enough to go through.
The thrusting spear appears to be more lethal. But to be sure, Lodes wants to conduct another battery of tests, this time under controlled conditions. At the University of California, Berkeley, Lodes will evaluate both prehistoric arms, applying technology used for ballistics tests. Using an air cannon, Lodes can replicate the force of a Neanderthal's thrust and compare it to that of a modern human throwing a spear.
The actual design is different. Being a throwing spear, we've got a slightly more slender shaft, so there's less friction on the shaft.
The forensic gelatin will give a clear view of each weapon's destructive power. First, the team wants to test the modern human throwing spear. Lodes knows modern humans still needed to get close to their prey to hit their target with accuracy. From prior experiments, he estimates the average range was no more than 9 to 12 feet. But how deadly is a throw from this distance?
Firing in 3, 2, 1.
The spear sends a shockwave through the gelatin, but it doesn't penetrate past the binding on the spear tip.
Okay, bad. So that was at 2/3 of our Neanderthal thrust. So that's representing early modern man throwing. But it's done pretty good.
With a throwing spear, force dissipates in flight. Lodes believes it would typically strike with about 30% less power than the thrusting spear. Now it's time to put the Neanderthal thrusting spear to the test.
Oh, yes.
Wow. That's pretty impressive.
that's just cut cleanly.
Look how far that goes in.
And dragging that material behind.
That's right.
That's causing colossal interior damage and bleeding, and just the shock alone, huge. It would stop the heart possibly, even just the force of that.
In Lode's tests, the thrusting spear not only stands up to the modern human spear, it stands out as the more powerful weapon, a strength of Neanderthals, rather than a weakness for mankind to exploit. With a body type tailor-made for the cold and technology perfected over 300,000 years, Neanderthals clearly had the advantage in Ice Age Europe.
Modern humans showed up, but the Neanderthals persist for a good long time after modern humans appear out of Africa. And it takes a long time for modern humans to succeed in the habitats where Neanderthals are still going strong. You know, they were able to master the environment that they lived in.
There are still people who will argue that these Neanderthals were somehow inferior, and it's our arrival that irrevocably eliminated anything that stood in our way. I think it's total nonsense.
Today, a consensus is emerging. Modern humans did not kill off the Neanderthal. So what was it that put them at a disadvantage? For decades, scientists believed that unlike modern man, Neanderthal clans lacked the strong interpersonal bonds that provided security and protection. But even this assumption is being challenged. In Mettmann, Germany, a 60,000-year-old Neanderthal skeleton provides proof that modern man was not the only species with strong social bonds.
I mean, it's amazing that the entire skeleton is sort of laid out here.
Yeah. See, it is an extremely well preserved skeleton.
The skeleton is intact, encased in earth tightly packed around it. Proof that Neanderthals were possibly the first humans to bury their dead.
So it wouldn't be preserved this way if it wasn't like a body that went into a hole.
Yeah. Exactly. It is still articulated.
The right arm crosses the body, as if it was carefully posed before the deceased was laid to rest.
So I think it must have been put in a burial pit and covered with clay so that the scavengers, hyenas and so on did not disturb it.
This is just one example of a Neanderthal burial, and it is just one of many burial traditions now linked to Neanderthal.
We're looking at a range of traditions, just as it's variable among living human populations. You have these bodies that are laid out aligned with each other. And then you have a large stone placed over it with marks on it.
Although the exact meaning of their burial practices is shrouded in mystery, the fact itself is telling.
When we look at the way they were treating their dead, it shows us that they were doing so in a way that we recognize as human.
If they're burying their dead, they have some kind of thought about an afterlife, and respect for those people who have died, and that shows how human they are and brings them closer to ourselves even more.
These new discoveries pose many questions about our closest human relatives.
What were and what are our relationships? How do we fit in with the Neanderthals? How can we understand their relationships to us? I think we have many questions.
The most pressing, if we are so similar, why did the Neanderthals die out while we survived?
That was a volcanic event.
They were in the wrong place at the wrong time.
New archaeological evidence has upended our vision of the Neanderthal as a brutish, unintelligent cave dweller.
We're just getting a little glimpse of the sophistication that Neanderthals probably had.
Neanderthals, it seems, were very much like us. And in one of the world's most remote and inaccessible fossil sites, archaeologists have unearthed evidence of a far greater connection between our species. In the Carpathian Mountains of Romania, a team of archaeologists is preparing to return to the site of a landmark discovery. A location that proves modern humans and Neanderthals once coexisted together peacefully. The exact location has been withheld to protect the site from fossil hunters. Here in 2002, cavers stumbled on a human jawbone. This led to a 3-year excavation, conducted by a group of archaeologists trained in cave exploration.
It's absolutely pristine. You can study a site which was completely new, undisturbed, which is very, very rare in the life of a scientist.
The scientists uncovered evidence that modern humans and Neanderthals may have inhabited the cave at the same time. The team retraces their steps down dark passageways and through an underwater river. As they venture deeper into the mountain, the cave walls narrow and the water rises.
There is no other way in the cave except this cold, wet place, and very dangerous too.
In the murky waters, they feel their way blindly forward, drawing on past experience to guide the way to the other side. Once through, they enter a large cavern with passages to smaller chambers. The team surveys the area. Then they head deeper still, towards the chamber that yielded their greatest discoveries. But the route is blocked by high waters that have flooded the cavern below.
You are in a narrow passage, absolutely alone. If you are stuck there somewhere, there is no way to escape. So if something happens, you are dead.
Safety concerns forced the scientists to cut this expedition short. But a decade ago, the team made it through the precarious passageway into a remote chamber. This revealing footage is from an expedition in 2003, a mission that paid off. The team enters a chamber deep inside the cave, called the Gallery of Bones. The floor is covered with animal bones, the remnants of bear and other large mammals prized by prehistoric hunters.
And I've already taken out several in this loose sediment here.
But scattered among them are human remains, mostly small fragments of fossilized bones, dating back 40,000 years.
It was absolutely crazy. I was so excited about everything around me. The bones in good state of preservation, it's absolutely astonishing what is in that cave.
On this dig, in a dark corner, a team member notices something.
That looks like human over there, under that long bones.
A fragment of a skull. It will become part of a larger, landmark discovery.
The skull was really something shocking. Very special for the history of humankind.
Now housed at the Institute of Speleology in Bucharest, the treasure is kept under lock and key, closely monitored by paleontologist Silviu Constantin.
When you look at this skull as a whole, this is a modern human with Neanderthal features. It's that sort of discovery which happens once in a lifetime. This skull was recomposed from 40 pieces.
It took Constantine and his team 3 years to reconstruct the skull and determine the exact features.
It has a long face, which is not encountered in modern humans.
The teeth are different too.
The size of them is too large for a modern sapiens. It is much closer to the size of the teeth of a Neanderthal.
And then the most telling feature of all.
When you look at the back, you find you have this occipital bone.
This protrusion shields the occipital lobe, where visual information is processed. The one area where Neanderthal's brain is larger than our own.
It's not typical for sapiens, but it's typical for Neanderthals. This may be the missing link, the link between sapiens and the Neanderthal.
For Constantine, the possibilities are tantalizing.
Imagine modern humans having love affairs with their Neanderthal neighbors.
From this ancient skull, a new image emerges, that of modern humans and Neanderthal interbreeding. It is the catalyst for groundbreaking discoveries about the mysteries of our own origins and who we are today. In a Romanian cave, scientists unearth a mysterious skull, a modern human bearing distinct traits of Neanderthal. This raises the question, are we somehow related to Neanderthal?
What are our relationships? How do we fit in with the Neanderthals? To me, it's still one of the most wondrous mysteries that we have about our origins, where we came from.
At the University of Washington, scientists are searching for traces of Neanderthal in our own DNA.
DNA is this wonderful, incredible informational molecule. It's almost like reading a book where stories of our past have been written in it. And the challenge right now is sometimes interpreting the words in that book.
Coiled up in our cells, long strands of DNA molecules determine and control our traits. A cell's complete set of DNA is our genome.
The genome specifies the development of the body plan, of the physiology of the organism. It's what makes humans human and Neanderthals Neanderthal.
In 2010, scientists mapped the Neanderthal genome. And when they compared it to the genome of modern man, they made a surprising discovery.
Essentially, everybody outside of Africa had Neanderthal ancestry. That number varies a little bit by population, but probably per individual, it's between 1.9 and 2.1% of the genome.
Within our own cells, the Neanderthals still live on.
We inherited those sequences directly from hybridization, and not because of just shared ancestry that dates back to 500,000 years ago.
The hybridization, or interbreeding, may date back to 60,000 years ago, when modern humans first encountered Neanderthals. The descendants of the hybrid offspring spread, eventually inhabiting much of the globe. But like Neanderthals themselves, never settled in Africa.
There was essentially 0% Neanderthal ancestry within Africa.
Aki and his team have systematically searched for parts of our DNA that we inherited from Neanderthals. In 2014, they compared DNA recovered from Neanderthal bones to the genome of more than 700 living people.
What's interesting is that the 2% of my genome that I've inherited from Neanderthals might be different than the 2% that you've inherited.
Adding up the different Neanderthal genes carried by people today reveals that much of Neanderthals' genetic legacy lives on.
Collectively, about 30% of the Neanderthal genome can still be found in individuals today.
But where does our Neanderthal heritage truly show?
We found about 10 places in the genome where we inherited a beneficial Neanderthal sequence. And quite strikingly, many of these regions contain genes important to hair and skin biology.
One example is a gene known to influence skin pigmentation. Among people of European descent, fair skin is a trait possibly inherited from the Neanderthal.
So European individuals at this place in the genome are more Neanderthal than they are modern humans.
Straight hair may be another Neanderthal trait we inherited.
It's clear that something about hair or skin biology of Neanderthals was beneficial to our ancestors. Maybe it helped our ancestors survive in these more cold, adapted climates.
But not all traits passed down from Neanderthal are necessarily beneficial today.
Some studies suggest that Neanderthal sequences in Europeans play an important role in genes that influence fat biology.
Today, this ancient trait may be contributing to an obesity epidemic. But in their Ice Age world, this adaptation enabled Neanderthals to build up fat reserves, advancing their survival, and perhaps that of our ancestors as well.
As we spread into these new environments, hybridizing with Neanderthals allowed us to pick up versions of genes and sequences that were already sort of adapted to that local environment. And it was a way for our ancestors to quickly adapt to these very different environmental conditions.
But this only adds to the mystery of Neanderthals' disappearance. If their genetic adaptations helped us survive, why did the Neanderthal perish?
Climatic causes, population causes, there could be disease causes, there could be differences in the way that you use resources as a cause. It really is a mystery why their disappearance took the process that it did. They had a long run and then they were just gone.
One clue may lie with where modern humans and Neanderthals lived. 40,000 years ago, modern humans inhabited Africa, Asia, Europe, even Australia. Their population had grown to a few 100,000. Neanderthals never numbered more than 100,000. Confined to areas in Europe and Asia, they were more vulnerable to regional events.
The Neanderthals succeeded in that environment. They evolved their special adaptations to cold, and they were successful over time there. But at the same time, that was a challenging environment.
Is it possible the environment grew too severe, too harsh for even the Neanderthal to bear? This volcanic lake, near Down in Germany, contains sediment dating to when Neanderthals inhabited the region. A pristine record of the environment going back over 100,000 years. Here, paleoclimatologists from the University of Mainz bore hundreds of feet below the surface to extract sediment core samples. Each layer, only a fraction of an inch thick, is a yearly record of climate and environment, captured in mud.
What is unique about these core samples is the fact that there is no oxygen at the bottom of the lake, so sediments are undisturbed. We are able to analyze layer after layer and can reconstruct the climate of a single year.
3 feet of sediment represents a 1,000-year climate record. Dark layers contain traces of decayed plant life, a sign of times when forests covered the area. Lighter layers mark colder periods, when the land became a barren, frozen expanse.
We see here rapid climate changes. Warm, then cold. It changes within 10 years. The Neanderthal here lived in a world with open forests, and then it's open steppe.
40,000 years ago, the Neanderthals' world is rapidly disappearing as their traditional hunting grounds turn to hardened permafrost. And the worst is yet to come. "40,000 years ago, centuries of drastic climate change have ravaged much of Europe, turning Neanderthal hunting grounds into barren fields of icy earth. To the north, countless Neanderthals perish from exposure and starvation. But others turn to one of Neanderthals' oldest survival tactics. They move. Sometimes hundreds of miles away from their traditional lands. Far from the protection of caves, Neanderthals erect tents fashioned from hides. Adaptations, survival strategies, and skills developed over the course of 300,000 years see them through the era of drastic cooling and encroaching ice.
It was a challenging environment. It was challenging in terms of climate. They were fulfilling those challenges. They survived those challenges.
But the centuries of unrelenting climate change do take their toll. They deplete the Neanderthal population to possibly no more than 20,000, pushing the species towards a precarious tipping point.
My suspicion is that the population of Neanderthals were probably very highly dispersed in the landscape and very, very small. And this lends you to the possibility of chance events affecting you, even catastrophic events, could a volcanic eruption or a tsunami if you're on the coast. These things can really have a significant impact when your populations are that small.
And volcanic eruptions in particular have changed the course of human civilization time and time again. April 10th, 1815. The eruption of Mount Tambora on the island of Sumbawa in Indonesia is the largest volcanic event in recorded history, killing over 10,000 people in its immediate vicinity. The ejected ash and gas circle the Earth and block out the sun. The following year is known globally as the Year Without a Summer, causing crops to fail, livestock die off. All told, an estimated 90,000 people perish worldwide. Lake Ilopango. In 535 AD, a volcanic eruption in El Salvador buried 4,000 square miles in 3 feet of ash, stopping all agriculture for a decade, nearly wiping out civilization in Central America. But Lake Ilopango or Mount Tambora are not the only global volcanic disasters, nor are they the largest. Lake Toba, Indonesia. This is a supervolcano, one of nature's deadliest killers. Its placid waters cover a collapsed caldera, spanning across 440 square miles. 74,000 years ago, molten rock and superheated gases expanded until the Earth's crust could no longer withstand the pressure. The blast produces a mushroom cloud of sulfuric acid and gas, 100 times greater than the Mount Tambora blast.
That catastrophic eruption changed the climate, probably wiped out a lot of populations in that area.
It spreads ash across Asia, the Arabian Peninsula, and even Africa. India, over 1,000 miles from the blast, is buried in up to 18 feet of debris. The Mount Toba eruption altered the environment for decades, if not centuries to come, with deadly consequences.
You could have a perfectly genetically fit population, which could disappear overnight because of a volcanic eruption. And no matter how fit genetically they are, they've gone, and they're gone forever.
Did a volcanic eruption seal the Neanderthals' fate? The Greenland ice sheet may provide the answer. The ice here forms a frozen vault. Locked within its layers, years of ancient climate data.
So we're flying over the mountains, takes us right up to Kangaroo Shack. It's really beautiful.
Accessible by Special Air Force transporters, the Summit Camp Research Center sits at an altitude of 10,000 feet, atop a literal mountain of ice. Here, scientists like Jim White drill thousands of feet down to extract core samples from deep below.
Imagine that snow never melted. Imagine that snow just keeps piling up and piling up and piling up. In places like Greenland, where we have a meter of snow per year accumulating, those records go back maybe 150, 160,000 years. But that's certainly a long enough period of time for us to really get a good snapshot of what the Neanderthal had to deal with.
When extracted, gases and sediments trapped in the ice will paint a vivid picture of our planet's history.
We measure temperature, things like the amount of dust that comes in, the composition of the atmosphere, how much methane, how much CO2. So if there's a very large volcano that goes off, it puts ash in the atmosphere. It also puts sulfate in the atmosphere. And if some of that sulfate falls, as it probably will, in a place like Greenland or Antarctica, we're able to go back and measure that and say, yes, there was a volcano at that time.
Ice cores retrieved from the Greenland ice sheet are taken to a deep freeze storage thousands of miles away. The National Ice Core Lab in Denver, Colorado. It houses 60,000 feet of ice core samples, waiting to be analyzed.
This is a Fort Knox of ice cores. This is our gold, if you will. This is the most precious stuff we have.
Geologist Jim White has secured access to an ice core sample from the approximate time of Neanderthals' disappearance.
So that's the core from roughly 39,000 years ago. Yep.
White has been at the forefront of ice core research since the 1980s. He knows how to interpret clues hidden within this frozen history.
So the Neanderthal were alive when this snow fell, which is kind of cool and very interesting.
This time, he's looking for chemicals and compounds linked to volcanic eruptions. Ash, shards of volcanic rock, sulfur compounds, all distinct markers of an eruption, may be trapped within this ice core.
This one has several bands. There's a couple of nice thick layers that may be potentials for the volcanic event.
Yeah, so you can see there's a cluster in here of thin layers and another one right back in here.
The clusters are unusual. They appear to be dark bands of microscopic deposits suspended in the ice.
When we run that in the lab, we'll watch for that. Okay. That's something interesting.
Back in the lab, the ice core is melted, layer after layer.
What actually is happening here is we're peeling off week by week, month by month, year by year, the snow that fell. And that's then going into the machine and being measured. It's like leafing through the pages of a book, one page at a time. In this particular case, we're probably looking at 1 year for every 10 centimeters or so. So it's a pretty detailed record that we're getting.
Particles and chemicals previously trapped in the ice are isolated and evaluated.
I can imagine that the Neanderthals would have been very much surprised by everything they see here, but probably no more so than surprised by the fact that we know what's going to happen to them.
Finally, the ice reveals its long-hidden secret. Remnants of a volcanic eruption.
We can see the sulfate from the eruption. We don't see ash or anything in Greenland, but we can see the sulfate from that eruption. And we know that it occurs right at that same time where you have this very sharp cooling in the ice core, right in here.
A clear indicator of a massive eruption with far-reaching consequences.
That was a volcanic event that was certainly one of the largest in the last couple 100,000 years. That would be a very challenging time to live.
Is this the smoking gun? Could it finally explain the mystery of Neanderthals' disappearance? In the south of Italy, scientists investigate the possible culprit. One of the largest volcanoes in the world, and the largest in Europe. This sleeping giant is known to have erupted 39,000 years ago. And it may be waking up again, threatening the lives of millions today.
Gas flux in this area has increased dramatically in the last few years. There is an urgency to monitor continuously.
Naples, Italy stands on shaky ground. Mount Vesuvius looms 6 miles away. But Vesuvius is not the greatest threat to the area's 4 million residents. A much larger, deadlier volcano rages practically underfoot. Campi Phlegrae, Europe's largest and most dangerous volcanic site. Its caldera is 8 miles wide, most of it hidden under the surface of the Mediterranean Sea. This is a supervolcano. At the Volcanology Observatory in Naples, scientists scrutinize every inch of the raging cauldron. Tidal gauges measure the exact level of the seabed, while seismographs search the ground for any signs of underground quakes.
There is a need, an urgency to monitor. If to imagine inside the caldera, there is a population of about 500,000 of people that live here.
Within the caldera, noxious sulfuric gases rise from cracks in the surface. In pools, volcanic mud boils, superheated to over 300 degrees. Scientists register alarming signs of activity.
Gas flux in this area has increased dramatically in the last few years. The ground at the moment is rising, yeah. There is an urgency to monitor continuously.
In the past 30 years, the ground around Campi Phlegrae has risen by more than 6 feet. The volcano is so active, it has already forced residents from their homes.
Follow me. I'll show you a very interesting phenomenon. In this abandoned building, you can see how aggressive are these sulfur components. Wow.
Sulfur and gas have forced their way up through the floor and into the walls.
90 degrees, bro.
No, more.
Even 100.
But the most troubling signs are further afield. In the hills nearby Naples, Antonio Costa and Roberto Izaya are searching for remnants of the volcano's violent past. traces of an ancient eruption that may be linked to Neanderthals' extinction.
Questo è l'affioramento che ti dicevo, vedi? E questo, this is the layer that we are talked about before, this one.
These cliffs are over 200 feet high. They're composed of volcanic debris deposited during a single eruption. Their height alone points to the sheer power of this blast.
That's the ash. That is the ash.
Ash from this cliff has been carbon dated to approximately 39,000 years ago, the time of Neanderthals' disappearance throughout most of the world.
Ashes like this, very fine ashes like this, you can imagine we're going around in all the Eastern Mediterranean, very far from the Campi Phlegraei area.
But was this eruption powerful enough to wipe out the Neanderthal?
I think that an eruption in Italy could have been significant. My question then would be, what is the extent, the geographical area? Is it greater than we've suspected?
The answer may lie in the ash. Scientists can gauge the strength of an eruption by measuring the thickness of ash layers in locations far from the volcano. In Romania, 700 miles away from Campi Phlegraei, geologist Daniel Verez searches for ash from the ancient eruption. A clue to the blast's power and perhaps the cause of Neanderthals' extinction. He's joined by fellow geologist Ulrich Hambach.
Let me take a sample and have a closer look. It's much lighter than the loess. I think it can be a volcanic ash done. Really?
It does. It has the consistency.
Yeah, it has the consistency.
Hambach and Verez are one of several teams investigating the size and impact of the Phlegraei blast. This ash may get them one step closer to the answer.
The thickness of the ash at this particular spot is 1 meter and 10 centimeters, and it's even increasing.
To the left, to the center of the depression, which is at the moment covered here by the debris.
By measuring the layer's height, they can begin to calculate the power of the blast. Here, over 700 miles away, the volcano dumped 4 feet of ash on the region.
I mean, this is a very unexpected find. The eruption that created this particular layer must have been of a very powerful magnitude. If this is the eruption of the Phlegraean Fields in southern Italy, as we suppose it is, it certainly proves that that eruption, which was considered as the largest in the last 200,000 years, has been likely even of higher amplitude than expected.
Verez and Hambach are not alone in this work. Throughout the Mediterranean, up to Russia and into Asia, scientists have collected and measured ash dated to 39,000 years ago. Samples are sent to the University of Bayreuth in Germany. Here, Ulrich Hambach analyzes them to determine if they originated from the Campi Phlegraei eruption. All volcanic ash has a specific chemical fingerprint that is unique to the blast that deposited it. Using an electron scanner and an X-ray beam, Hambach and his colleagues create a specific chemical profile of each sample.
We are really curious and we hope that the results will match the eruption in Italy.
The tests reveal the chemical components of the ash samples. Each sample has an identical chemical profile, a profile that matches a single eruption, the Campi Phlegraei blast.
It's the same for the sites we investigated, and it's the same for the sites colleagues investigated from Russia down to Libya.
The research shows the terrifying scale of the blast. The eruption spread ash across 3 continents, encompassing large swaths of the territory where Neanderthal once lived. Back at the Naples Volcano Observatory, Antonio Costa is preparing a computer simulation of the Campi Phlegrae eruption. Once complete, it will reveal exactly what happened 39,000 years ago. At the observatory in Naples, Antonio Costa and Roberto Izaya are generating a computer simulation of the Campi Phlegrae eruption 39,000 years ago. The cataclysm linked to Neanderthals' extinction. The simulation reveals the sheer power of the eruption.
For the first time, we were able to estimate even the duration of this eruption. We estimated that the eruption lasted between 2 and 4 days.
Using this simulation, the scientists can piece together what happened 39,000 years ago. The Campi Phlegrae volcano looms above the land. It will soon come crashing down. Neanderthals nearby feel the first signs of an imminent eruption. A barrage of tremors emanating from the volcano. It's the most powerful eruption in Europe in the last 200,000 years. Pyroclastic flows burst from the volcano, rampaging over a 40-mile range. The cascade of gas and molten rock, superheated to over 1,500 degrees, travels at speeds approaching 500 miles per hour.
Obviously, where the pyroclastic flows arrived, there were no chance for any kind of life to survive. Everything was buried under meters and meters of flows.
A mushroom cloud of volcanic gas and fiery debris rises into the Earth's atmosphere. A thick layer of ash engulfs much of southern and eastern Europe. Within days, the cloud spreads to Central Asia and the Middle East. But where the modern human population is spread around the globe, Neanderthals are confined to Europe and Central Asia, the regions most impacted by the blast. For most, there is no hope of escape.
4 million of square kilometers were covered by at least half centimeter of ash.
The cloud of debris blocks the sun for weeks. Ash rains down on an area that stretches from Russia to North Africa.
So conditions in Europe at that time were already very difficult. Then on the top of this condition, we had a volcanic winter.
In the ash zone, Neanderthals and modern humans face a slow and torturous death.
Even half centimeter of ash is able to kill completely the small vegetation that existed at the time.
The smothering ash blocks sunlight and oxygen. It also contains high levels of fluorine, a deadly chemical for plant life.
When vegetation die, animals die, and the humans as well don't have a source of food.
Many Neanderthal wither away and slowly die from starvation. Others develop symptoms of severe fluorine poisoning, chronic fatigue, nausea, and eventually death. The first ones to die are the children and the elderly. But deprived of food and light, even the strong do not survive for long. Vast forested lands where Neanderthals lived for millennia are now desolate, inhabited by dying members of a doomed species.
In areas like in the Eastern Europe, we had to wait for sure centuries for that ecosystem to flourish and go back as it was.
Across much of Europe, modern humans and Neanderthals are completely wiped out. Only Neanderthals on the outer reaches of their territory survive. The place they survive the longest, the Rock of Gibraltar. For another 15,000 years, they live on as they always have, unaware they are the last of their kind.
So they just carried on living their day-to-day lives as best they could, and gradually their numbers dwindled, and one day just disappeared.
Leaving behind their caves and their remains for our own species to discover. A species that could face the same fate. Today, 39,000 years after the catastrophic eruption, Camp Phlegrae continues to rage. Another super-eruption is not likely to happen anytime soon. But if it happens, it could decimate an entire continent. And volcanologists are on high alert.
The gas composition has changed recently and has more magmatic components. We monitor it routinely every 2 weeks.
And even for those who live far away from this monster, there's every reason to be alarmed. This is by no means the only active supervolcano, or the most dangerous. Supervolcanoes dot the globe, 23 total, threatening populations on almost every continent. And the most powerful of all is in the United States. Northwest Wyoming. Yellowstone National Park spans over 3,000 square miles of pristine wilderness, untamed wildlife, and unique natural wonders. The park contains half of the world's geysers, one sign of the violent forces raging beneath the surface. This is the world's largest active supervolcano.
Yellowstone has produced 3 eruptions in the last 2.1 million years, at least 2 of which would easily qualify for a super-eruption, perhaps all 3.
Park geologists estimate that the volcano erupts every 600 to 800,000 years. The last time was 640,000 years ago. Yellowstone is due for another blast.
We know that the magma chamber is close to a point at which it could be eruptible.
Based on U.S. Geological Survey projections, an eruption would have catastrophic consequences. Searing ash and molten rock would surge across the land, destroying everything for miles. Billions of tons of volcanic debris would jettison upward into the atmosphere, forming a vast cloud of ash. Carried by the wind, it would travel over 2,000 miles from the blast zone, enveloping most of North America in a coat of ash.
Super-eruption would literally change the face of North America. There would be ash accumulations we couldn't deal with. There would be infrastructure costs, which would be prohibitively high, so we would have to be very careful, prioritize how we rebuilt. These are some of the obvious things.
Across the country, crops and livestock would perish, depriving North America of food. Noxious sulfur compounds would poison the water supply. Buried in ash and debris, roads and infrastructure would be obliterated, cutting off the lifeline to major cities on the East Coast and relief for survivors of the cataclysm. In a matter of weeks, the world's greatest superpower would crumble, and the devastation wouldn't be confined to North America.
super-eruptions put up a tremendous amount of material into the atmosphere. That could definitely be felt globally.
Around the world, the sun would appear to dim, its light diffused by volcanic debris lingering in the high atmosphere. It's a precursor to the darkest phase of the cataclysm, volcanic winter, a period of cooling that can last for years. Experts believe a Yellowstone eruption would result in the devastation of global agriculture and lead to severe food shortages and mass starvation. It would threaten the very fabric of civilization.
It would be a changed planet. But I think the human endeavor is resilient. I have great faith in our ability to survive these kinds of things.
And the chances are we would live on, for the same reason our species survived the eruption that doomed the Neanderthals. We inhabit every corner of the globe. We can withstand a cataclysm that devastates 2 continents. Neanderthals, a species without our global reach, could not.
I think in the end they were in the wrong place at the wrong time, and one population made it, which is us.
They did not die out because they were intellectually inferior.
They lived lives that were very much like the lives that people live now. They didn't have some of the ways that we organize large societies, but when you look at what they achieved with those limitations, it's very human.
They roamed the planet for 100,000 years longer than modern humans so far.
Certainly if there was a Hall of Fame of humanity, the Neanderthals would make that Hall of Fame.
In a sense, we owe them our lives.
We should be pretty grateful to Neanderthals because they helped us survive and reproduce as we migrated out of Africa into these new environments. So they played an important role in human evolution.
And so, their legacy lives on within us.
Perhaps we can say that we have met the Neanderthals and they are us.
The Neanderthals reigned for 300,000 years. Whether we survive as long is a big unknown.
I think it's a matter of chance, and like I often say, you know, if it had gone another way, you know, we would be Neanderthals now talking about the extinction of the other people.
I don't think we'd be able to recognize the Neanderthals today if they were just out on the street. Not only would they probably succeed in modern society, at some professions they probably would have been better than even us.
We are the sole human species on the planet. But the Neanderthal do live on in our DNA, perhaps strengthening our ability to cope with the challenges of life on Earth and survive when they could not.